What's up, everybody? Happy Monday to everybody. What is up, Tom Smith? Thanks for tuning in tonight. Guys, let me know if anything sounds out of line, if the music's too loud, if my voice is not coming through clear. I'm counting on you guys to let me know that everything is sounding and looking good. It's great to see everybody here. What's up, Cough Cough? What's up, Rodrigo? Thanks for tuning in. JMG, great to see you here again. What is up? Workshop 1668, thank you so much for tuning in. Love your icon. Think that's awesome. And, of course, superstar Eric Beatty is here today. Welcome, Eric. Thanks so much for tuning in, joining us tonight. So tonight we are going to talk a little bit about Model Monday Solved. This is where we take a look at our SolidWorks modeling challenges from Saturday, and we see if we can't figure out how to build those challenges the best way possible, maybe. Hopefully like the most efficient way. Hopefully we share some tips and tricks. This has been a nice fun series that we have done here. I like to call it live solves. Model Monday live solves, but unfortunately this is going to be the last episode for a while because I really need to hunker down and start focusing on the tournament, which is coming up on May 1st. So not going to be able to keep doing these Model Monday live solves, but I hope that you have found them helpful. And of course there's I think I did 5 of these, including this one tonight. So you should have lots of material that you can pull from if you look back over those past kind of 5 episodes. And so, especially if you're a newer user, if you're a student, I think you'll really be able to extract a lot from the kind of just like looking over my shoulder as a SolidWorks expert and kind of seeing how I go through and think through these challenges. So hopefully that's what you're getting out of these, and hopefully we've done a good job of getting you, a lot of good content up to this point. But like I said, I just got to really focus on the tournament, doing the tournament right, because it's coming up. I can't believe it's already coming up. There's only really, I think, 4 more episodes of Model Monday Live, which is like Saturday speed runs. There's only like 4 more episodes of that, and then boom, we're at the tournament. So it's crazy to think that, but that's what we're going to be going for here. And again, huge shout out to Eric. Thank you so much for helping me get the sound right. And let me say what is up to my good friend Table36. Great to see you in here again. Like I said, this is a representation of Saturday speed models. So if you were here on Saturday, you had a chance to try your hand at creating some of these models. Tonight, I'm going to show you how I would approach them, how I would build them. I want to give a quick shout out to the SolidWorks Discord. It's an unofficial SolidWorks Discord. It's not affiliated with Dassault Systems or anything, but there are some great users in there helping each other out, some great people in there that'll definitely help you out, especially if you're a student and you're maybe running into some challenges, some specific challenges. There's definitely some good help to be found in there. Also want to give, again, huge shout out to Eric, who reminded me that on April 6th, the Seattle SolidWorks Users Group is going to be hosting their 25th anniversary. I believe they were the very first users group to start up. And so Eric is going to be hosting the 25th anniversary, so be sure to look for that. You can probably just search for SASPUG SolidWorks, and you'll find his users group. They're going to be doing a 25th anniversary special. I saw there's at least 2 other meetups. I saw Betty Baker's meetup and the Aberdeen meetup are helping kind of co-celebrate this event. So if you can't figure out how to register for his, I'm sure you can figure out how to register for one of those other ones, and you can join in on the festivities. I know that it's going to be a pretty cool night with some great presentations, so I am super excited to be there. I think that's a week from tomorrow, if I did my math right. So you guys want to make sure you mark that on your calendar and you tune into that event. It's going to be awesome. He says, yep, we were the first. I had no idea at the time. That's awesome, Eric. All right, so we're going to go through 3 challenges today. The way that we did it on Saturday was you could only win 1. So you can only get 1 point on our TooTallToby leaderboard. This is on TooTallToby.com on the Model Monday Live tab. You'll see that there's a leaderboard. This is what the leaderboard looks like currently. So we got 7 people in first and second, and then we have 2 people in third. So in other words, we have 1 person with 4 points, 6 people with 2 points, and 2 people with 1 point. The Parge and Rodrigo are a little bit out of order. I apologize for that. But that's kind of the standings right now, and we're going to iron these out this month, although I think we're going to really shake some things up this month. What is up, Ray? Thank you for tuning in. Always good to see you in here. Longtime friend of the show. So good to see you in here. Whenever we do these models, these are the materials and densities that we use. So if you haven't done one of these models before, be sure to take a look at these materials. Maybe grab a screen capture so that you're sure that you're getting the correct materials. And with that, what we do is we let everybody see this print all at the same time. So this first print was called half sleeve, and this is what that print looked like. So we would say, 3, 2, 1, go. We'd show this print. I would encourage you to take a screen capture of this, and if you want to follow along with today, you can certainly do the same thing. Take a screen capture of this, and then what you're going to do is you're going to try to model it, and you're going to try to come up with the correct mass. There was actually a misprint on this when I posted it on Saturday. I kind of corrected it on the fly, but I had the correct material listed, but the incorrect density down in the corner. So just give you guys one more chance if you want to take a screen capture of this, if you want to kind of follow along with as I'm giving this tutorial. It might be helpful. If not, you don't have to. I'm going to take a quick sip of my water, and then we'll get into this first model here. All right, I hope that was enough time. So what you can see here is that this model, this print, it's a little bit different than some of the prints that we've done in the past, just kind of in the sense that it has some mystery dimensions built into it. And what I'm speaking of specifically are these dimensions here. So this question mark, question mark, question mark, this question mark, question mark dimension. And I was going to originally just leave them off altogether, but I was worried that people would think that it was a drawing error. And, I'm kind of on the fence about my decision to have included these as question marks because it turns out I ended up having a drawing error anyway. Down here in the corner, I had a drawing error, and the drawing error was that the material said plain carbon steel, but the density was incorrect. I had it at 1020, which is the density for ABS. So this is an opportunity to kind of learn a lesson from this, and the lesson is, don't stop if you run into a discrepancy on a print. This happens all the time in the real world. You get a print from a customer, there's 2 dimensions that are conflicting. There's an inconsistency with the way the title block is laid out, the information you're getting. Don't stop. Stopping is usually the worst thing you can do. Now, I mean, if the customer is just a phone call away, then sure, just pick up the phone and call them. But if you're not going to talk to the customer again until the next design review meeting, which is, in a few days, don't just stop everything just because there's an error on the print. Just keep plowing forward. Do your best. Use your best judgment, and and then kind of note where that inconsistency is, and kind of design that into your model so that when you do talk to the customer, you can quickly make that change if it was not what you anticipated it to be. So still kind of a good lesson there, and maybe that's another reason why I should have just left these question marks off, just to kind of let people struggle with this a little bit more. But ultimately what we're seeing here is that, a lot of times when I look at a print, I think to myself, I'm going to draw this thing from the top because this is going to capture most of the footprint. Well, I'm not going to be able to do that with this print because I don't know what this dimension is, and I don't know what this dimension is down here. So drawing this thing from the top and trying to capture that footprint isn't going to work. And so instead I have to kind of use my engineering intuition and try to figure out, okay, what can I draw? And it turns out that I can draw this view here. So I could draw a line that comes up. I can draw a line that comes up and over, not tangent or an arc. I can draw a flat spot here. I could draw a line that comes down. I could draw this final flat spot here. And, you know, I do have enough geometry in the print to draw up that shape. So that is going to be the shape that I'm going to draw. Now, the model looks to be pretty much symmetric. I even put this kind of cheesy note on here that says the model's mostly symmetric. So in this spot, I'm definitely going to take advantage of symmetry. I'm only going to model half of it. A lot of times it just kind of makes things easier when you are just kind of modeling half of the design. You know, you don't have to do the whole thing. It's not only about it saving time, but it also kind of gives you that anchor point right down the middle, which a lot of times both in SolidWorks and in simulation can be useful to kind of constrain your model. So it's got, it's got multiple benefits here. So I'm going to jump into SolidWorks here. We're going to be using SolidWorks 2020 tonight, but most of these tips are going to apply to other versions of SolidWorks. You don't have to be using SolidWorks 2020 to take advantage of some of these tips and tricks. And I'm going to get into it here with a new part. I'll use my TTT templates here. I'll choose a part in plain carbon steel and MMGS. I'm going to move my PowerPoint here off to my other monitor. So whenever you see me looking up this way, I'm just looking up at my other monitor. And I'm going to stick to my plan, which is to go to the front view and create that first shape. And so for this first shape here, what I'm going to do is I'm going to come over, or actually I'm going to come up here to the distance. I'm just going to do the full distance of that radius, which is 100. So I let go of my mouse, I move over here, I type in 100. Now I come off with another line. Now I'm going to come back and touch that endpoint, and then I'm going to come off of that endpoint with an arc, which is automatically tangent to that endpoint. So it's just a nice shortcut to learn about. I've talked about this in previous episodes, but you should definitely get comfortable with that idea of making an arc tangent to a line from within the line command, but also making an arc tangent to the perpendicular of the line. So I'm going to make this arc kind of come down here like so. Its radius is really going to be defined when I lock it into the origin, so I don't really have to worry about that. And then I'll just create a line that kind of comes over like so. I'll take this point here, hold control, pick the origin, let go of control, make that coincident or merge points. Same thing with this one, merge points here, and that fully defines that sketch. So what I'm doing there is I'm just kind of looking at this front view and I'm saying, okay, this has a radius of 100, and it's got a flat spot on top here. Well, why don't I just make that radius of 100 come all the way up to the top and then just kind of drop it over like that and drop it back like this. Now, the problem is that this is actually not tangent. It's a flat spot here, right? So I probably shouldn't have made that radius go all the way down to the bottom, but I'm just kind of getting myself set up for, the next step in this sketch. So now I can come over here. I can take a line, make a line vertical like so, right? I can trim this geometry. So just kind of trim this off. There we go. Boom. That's fixed. And then I just need to put in the height there, which is a height of 20, and that should fully constrain that sketch. So, a big reason why this is nice and fully constrained is, well, one, I'm keeping it simple. I'm not putting the flat spot up top. I'm, keeping it simple. I'll make that as a second feature. And two, because I'm using symmetry, so I'm only having to model half of this, so I don't have to worry about, making these 2 points horizontal if I had another line over here or, any of the other additional complexities that come with modeling the whole thing instead of just doing half of it. So I go features extrude. I'm going to take us out to 15, enter. Again, just saving time by never having to go up to the toolbar or go over to the property manager. Just kind of 15, enter. And now this next feature that I'm going to create, again, what I would love to do is I would love to create this kind of top shape here, but I still don't have enough information to do that. So instead, the next shape that I'm going to create is actually going to be this other arc that's sticking out here. And I'm just going to take note that that arc is going to a depth of 95 millimeters. So I'm going to try to just model it on this rearmost face to save me the extra step of having to back calculate, 95 minus 15, which is easy in this case, but it's often a lot more difficult than that when there's real world numbers involved. So that green geometry that I just sketched is going to be represented as this geometry here, where it comes up to a flat spot, comes across like this, comes down, comes across like so. That's going to be my second sketch. So create that sketch, and then bring it out to 95. Pick this face, begin a sketch, orient my view. Basically rinse and repeat what I did a moment ago. So come up with a line. That line is going to go to a radius of 60. I'm going to come away from that line, still in the line command, the click, click, click method. I'm going to come back and hold my mouse over that edge or over that endpoint, bring a line over to here. Now I'm back in the regular line command. I'll just make a vertical line, kind of learning from my previous mistake where I had to trim that off. And then I'll take this point and make those horizontal. And then finally what I will do is take this arc, click on its center point, hold control, click on the origin, and merge those points together. Fully defined sketch. So, you know, a lot of these steps we've talked about in previous episodes of Model Money Live Solve, and we've also talked about these in Power Moves, in the Power Moves episodes. So hopefully they're starting to really resonate with you now. But just remember, you know, it's all about kind of those key things that I'm doing there. I'm going to Control Z here, you know, or just little things like getting comfortable with the idea of pick one, hold control, pick the other, let go of control. And then just don't go crazy with your mouse, you know, and then lose that relationship and have to come over here. Just kind of like know where that box is going to show up as soon as you let go of control. It's when you let go of control that box shows up. I think actually the name of that power move is letting go of control. So if you want to go back and look at that video, it's called letting go of CTRL. It's a little pun. All right, now something we talked about last week was whenever you do an extrude, the default direction of the extrude is going to be away from the face that you selected if you sketched on a solid face. So that means that I can predict when I go S key extrude and I type in 95, it's going to be going the wrong way. So now I'm going to, you know, come back away from the 10 key, come back over to my mouse. I'm going to right mouse button, reverse direction, and then right mouse button again. Again, I mean, these are they might seem like they're like, oh, he's just using all the shortcuts just to look cool or whatever. But they're really useful time savers when you learn how to predict what's going to happen with the software. When you learn how to maximize the use of those shortcuts. I mean, look at how fast you can do that. S key, extrude, 95, enter once to update the preview. Then I take my hand over to my mouse, and I know that if I right-click right now, it's going to finish the command, and that's not what I want. So I know to kind of move a little bit away first, get that little right mouse button icon to go away. Then I right mouse button in reverse direction, and I know that the next thing that's going to happen is that it's going to show me that right mouse button equals green check mark again. So as soon as I left-click reverse direction, I immediately right-click, and that finishes the command. And so in real time, it looks like this. S key, extrude, 95, enter once, move the mouse a little bit, right mouse button, reverse direction, right mouse button again. And it's just these are very fluid movements, but it's really a combination of several little steps that I've learned just through practice, kind of anticipating what's going to happen next. I know from experience that if I right mouse button right away, it's going to finish the command. That's not what I want. So I know from experience just to move it a little bit, then right mouse button, and then I know that as soon as I choose reverse direction, the very next move I'm going to make is going to be to right mouse button again. So it's going to be like left mouse button, right mouse button, you know, really quick. So now I finally have enough information that I can create that geometry on the top of the model. So I can pick this face, begin to sketch. Control 8 gets me normal 2. I want to be looking at it normal 2 the other way, so I just press Control 8 again. Now I'm looking at it from the other direction, and now I can S key line, create a line that comes over here like so, out to this endpoint, comes straight out to a distance of 50, enter, comes over here to this point, click over to here, click over to here, click over to here, and now I sketched on the bottom face. So once again, when I go to extrude, the default behavior is going to be that it's going to be extruding the wrong way. So I could type in the depth 20, do a reverse direction. So I go 20, enter, move my mouse, reverse direction, right mouse button again, and then boom, there we go. Tambora Station says, Toby, when you change the plane colors like you did last week, is that a savable operation? I have reset the colors every time I start SolidWorks. Maybe it's just my older version. So usually the answer to that is, so this came in on chat, guys, just in case you're wondering. This came in right here on chat. So usually the answer to that is it a system option or is it a document property? That's how you can figure out the answer to that. So if I go in here to my options and I go to, I'll just look at planes here. Plane, and then I've got Where's my plane option? Plane colors. Planes, 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 planes. Plane display. Okay, here we go. So we can see here, plane display, front face color, back face color. And what we're going to look at is we're going to look at these two tabs here. So this tab here, document properties, means it's only for this document. So it is a savable option, but the way that you would save it is you would make a new part, make that change, and then save the template over top of the existing template in that case. Because anything that's on this tab is going to be saved into your templates. So great question, Tamburro Station. I hope that answers it. That's how you got to fix that up. If it's on document properties, it is not going to store with your system settings. Oops. I just blasted that thing off into space, so I pressed F on my keyboard. That brought it back. Another good solid shortcut there. Okay, one last thing I want to say about this boss extrude that I just did is, in this case, I probably wouldn't do that trick that I just showed you where you do the reverse direction. Instead, what I would do is S key extrude, and then I would single click on a vertex, because what happens here in the extrude direction, I've talked about this a lot in the past. I've talked about this in my power move called end condition shortcuts or something like that. Right now it's set to blind, but if I single click on a vertex, then it automatically changes to up to vertex. So you see here, it automatically changes to up to vertex. And then also my mouse changed to a right mouse button icon. So as soon as I finish that sketch, I'm going to S key extrude, click on this point, and then immediately right click. There we go. That finishes that feature. And now for the final features, the cut extrude going down the middle and the asymmetric boss that's on this thing. So the cut extrude, you know, we would want to save this cut extrude for last. Usually you save your cut extrude for last. And then this boss over here. Well, this is probably the point where I would mirror it. Oh, I got to get my flat spot up top too. So that's 90 off the bottom to get that flat spot up top. So now I'm going to pick a face off the model, select it, you know, begin a sketch, orient my view, and I'm going to go to the rectangle command, single click here, and then I'm going to single click here on the arc. That's a good, quick, easy way to get that dimension in there, and then I'll dimension from here to here, and that's going to be 90. S key extrude cut, and this time we talked about this last week too. When you do a boss extrude, it comes away from the geometry, but when you do a cut extrude, it goes into the geometry by default. So I can just do extruded cut, right mouse button, through all, and then immediately right mouse button again. That gives us a flat spot. All right, I'm ready now to mirror, and when we do a mirror here, we're not going to say features to mirror because we would have to go through and pick all these different features, and sometimes they don't pick right. You have to like double click or do a weird thing, and sometimes they don't rebuild right when you mirror them because the end conditions are dynamic. So instead what I'm going to do is bodies to mirror, pick this body here, say merge solids, hit the green check mark. There we go. That gives us the mirror. Now pick this face, begin a sketch, orient my view, and S key circle. Drop in a circle here with a diameter of 13 times 2. And the reason I'm doing that 13 times 2 is because it is giving us a radius on the print. You can see that down here. So I'm just doing 13 times 2 instead of, instead of figuring out what it's supposed to be or like doing something tricky with the dimension. And then S key smart dimension from the center of the arc to that 58, and from the center of the arc or the bottom edge of the model, whatever you want to do there, up at 23. And then S key extrude, and this is another one of these shortcuts. Last time I went up to vertex, S key extrude, double click on a face. That's going to change this from blind to up to surface. Immediately right click. That finishes that command. Now this face here, begin to sketch, orient the view, wake up the center point, go to the circle command, make this a diameter of 10, S key, extrude cut, right mouse button, through all, right mouse button, and then pick this face here, same thing, S key, circle, drop it on the center point, make this one a diameter 75, S key, extrude cut, right mouse button, through all, immediately right mouse button again. And a lot of times people say, like, why'd you make those two separate cut extrudes? That's just the right way to do it. Like, I know it takes more time. If this was like a straight speed run competition, would I do it all in one feature? I probably wouldn't, just because like I'm a creature of habit, and I know that this is the right way to do it. Like it's not about trying to make your model in the fewest possible features. It's about trying to make your models quickly, but you still want them to be strong. You want them to be able to easily be changed. You want to be able to predict when you make a change. And in this spot, for all I know, the customer is going to come back at me and say, actually, I want that hole to be counterboard, or I want it to be countersunk, or, whatever. They're going to come back. The customer is going to come back at me and say they want something different on one hole, but the other hole looks great. So that's why I usually will go through and kind of segregate my features just from habit, just from knowing how customers are. And it's a good habit to get into. Don't try to combine too much into one feature, and kind of think about your customer, so that your customer, when he comes back to you, or he or she comes back to you and they say, can you change this? You're going to say, oh yeah, no problem. I thought that might be an issue. And they're going to be like, wow, this person really knows how to run this software. I'm really happy to work with them. I want to work with them again. And then they give you more work in the future. Rodrigo says, I overcomplicated this part so much. Didn't think about making the circles end in those straight lines. So I did it just half the circle with some delete faces. Really dumb of me. Listen, Rodrigo, screen name dark. You're never dumb when you're using delete face. Okay. Delete face is one of the best commands in the software, and any chance I get to use it, I try to use it. So, much love. All right, let's see if we got it right here. So we're going to go to evaluate. We're going to go to mass properties, and we're going to say that the mass is 4439.9, and the answer they're looking for here is in 4 places. So that's going to be 4440 if we got it right. Let's see if we got it right here. This is the big moment where we find out if it was right. Correct answer is yes. We did it. We got it right. All right, awesome. 1 point so far. I love it when we get them right. All right, cool. Well, Rodrigo, all joking aside, I hope that helped to show you maybe another way of doing this. There's always more than one way to do this stuff. And like I said earlier, ultimately, if you're creating your models in a way that they can be changed and in a way that they are predictable, when you go to make a change, you kind of know what's going to happen downstream. You know what's going to break, what's not going to break. Then you are winning. And it doesn't really matter how fast you make the models. The speed will come eventually, but learning that important lesson, learning that it's important to fully define your sketches, but it's also important how you fully define your sketches. It's important to think about, what does the manufacturing process look like? What do I know about this customer? What are some high risk features in terms of changing, right? Like, which features are most likely to change? Let's make sure that when we design the part, we kind of do a little bit of testing on those features and make those features easy to change. That's definitely going to set you up for a career of success. Table 36 says, I used selected contours for this. Wrong approach? No, not the wrong approach at all, Table 36. I think that's another great way to do this. So for those of you who maybe aren't familiar with that, the idea of selected contours, whoops, I didn't mean to launch that. The idea of selected contours, what you could do is you could kind of draw all this geometry on one sketch. So let's say I go to the front plane, and I'm just going to, just for sake of time here, forgive me, but I'm going to take this geometry here and I'm going to convert it. And I'll get rid of this guy here. Let's see, get rid of this. All right, get rid of these. Okay, and then let's make this into like an actual circle here, just to kind of have this thing be a little bit more realistic. So we'll go vertical there. We will make a line here like so, and we will take this shape here and just kind of capture it. Okay, and let's say we'll make a line across the bottom here too. Okay, I think that's probably pretty good. All right, now let's hide this solid body just so that we don't see it anymore. So let's say you went through and you created all that geometry in one shot. In fact, let's just to even further kind of illustrate this idea, let's do a co-radial tangent arc here. So I'll just do a co-radial. I'm just gonna make this guy here co-radial like so. So like, let's say we made that all as one arc, and then we're using that as our layout. Then what you could do is you could say, I want to take that whole sketch and I want to go to features, extrude, and then I just want to pick certain regions to extrude. So I'm going to pick these regions here, but not that flat spot up top, and I'm going to bring that out to 15 or whatever it is. Okay, and then I'm going to select another region from that sketch. Actually, I probably should have had. Oh, no, it's fine. So then I'm going to select another region from that sketch. So I'm going to pick the same exact sketch from the tree, and then I'm going to go to extrude, and then I'm going to come down here to my selected contours. I'm going to pick a different region. So I'm going to pick this region here. I'm going to say that's going to come out to 95. And, oh, actually, I want this to come out with that, or maybe even this as well, right? We could just do that whole thing in one sketch. And that's what's called a shared sketch. It shows up in the tree here with like a little hand underneath the sketch, like a Windows shared folder. So that's what's called a shared sketch, where you take one kind of master layout sketch and then you share it out to multiple features. And that absolutely would work as well. Table 3.6, definitely a completely valid approach. All right, cool. And then Eric says, for holes larger than what Hole Wizard preset offers, I use a simple hole option. And I saw earlier you said try to use a Hole Wizard for all circular cuts, just in case downstream benefits are what I'm thinking about too. Yeah, that's a great point. Again, if the customer comes along and says I want to turn that into a countersink or a counter bore, if you made that hole using Hole Wizard, that's going to be a much easier task than if you made it using regular cut extrude or a standalone feature. Okay, awesome. Well, I think that's a great spot for us to move on here. We got it right. That always makes me happy. Let's continue talking about these 3 challenges that we did on Saturday. The people who won on Saturday, that first one there was won by Parjiter W, or I like to just call him Parj because I can never say his name right. And he's got 2 points now on the board. You can see him there in slot number 7. So congratulations to Parj. And this next these points that you get earn you a spot in this tournament that I mentioned earlier. So, I told you guys earlier, this is going to be my last night of doing these Model Monday live solves, at least until the tournament is done, because I just really got to focus on getting some content, put together some promotional content. If you guys see any of my content go out and you can share it with people to kind of get the hype up and get some more people in there, it's a lot of fun when we have a lot of people in the chat. Watching, if you're competing, get your family to watch, cousins, your wives, brothers, sisters, anybody who you can get to watch. It's a lot of fun to have people kind of on the rail cheering people on. But these points that you earn get you into this tournament, and we've done this tournament now a couple of times. We did it back in June last year, and then we also did it in December. So this chart here is the chart that we used in December. So based on the points that people got, they were set up in this bracket. They actually are going to be randomly paired off. Once we get the top 8, I'll just draw the names from a hat. That will determine who goes against who in each bracket. And then if you win your match, you move on to the next match. And the way that you win is I show both competitors a 2D print. They are sharing their screen, and the competitors actually model up that part live, so everybody can see the way that their toolbars are laid out and the different commands that they use and the way that they think through these challenges. And it's very interesting to see, 2 different SolidWorks experts or professionals or, whatever you want to call them. I just call them all experts because they made it this far in the tournament. They're experts in my book. To see 2 different SolidWorks experts kind of fight through the same challenge and see which one comes up with the correct mass first. So we're going to be doing that this year in May, at the beginning of May, which is basically next month. We got about 1 month. And last time when we did it in December, none other than Cam Smith was the winner. He's going to be a guest on the show along with Eric Beatty and Todd on the 10th, April 10th. So come on back for that episode. It's going to be a good time. But this year when we're going to do it is on May 1st. So it's coming up here in just a few short weeks. May 1st. Season 3 tournament. All right, let's get on to the next challenge here. So this next challenge is a sheet metal challenge that I threw out there for everybody on Saturday. It's kind of a tricky sheet metal part. This is one of these spots where the customer gave us material inside instead of material outside. This happens most often with electronic enclosures. So you know what the dimensions of the PC board are. You kind of know what the interior height is of the heat sink or, whatever it is that's going on inside of that electronics enclosure. And so that's what those dimensions are given to the sheet metal team. And then a lot of times they just end up dimensioning it all to the inside and kind of building the material outside. So that's what's happening with this print too. So I hope that gave you enough time to do a screen capture of the print. If it didn't, you can just roll back and take a look at the video on demand here. All right, so as always, we start out with a game plan. When it comes to sheet metal, if I can and capture multiple bends, so like if I'm going down the center line here, if I can get this bend and this bend and this bend all in one shot for the sheet metal design, it tends to work out just a little bit more intuitively. This was a conversation that actually came up on Saturday. If you model the whole thing in just like a rectangle and then extrude it out, you don't actually get a parameter for bend radius in that user interface, so it becomes a little counterintuitive. So for me, this is what I'm going to try to do. I mean, I'm looking at the model, I'm seeing that it's symmetric, so I'm going to try and create that shape first, extrude it off in this direction. Then I'm going to try to create this shape as an edge flange, and then I'm going to finish off by creating this shape over here as an edge flange. I'll add in that slotted hole, I'll mirror it, and then I'll finish up by doing this keyway down the center. So this is the kind of stuff that, you know, if you're new to SolidWorks, this is probably the biggest thing you want to get in the habit of doing is trying to think about, you know, how to build the model using SolidWorks features. And it's not something you're going to do on day one, but it's definitely something you want to get yourself to the point of doing so that when you look around your house, if you're going to model something around the house, I don't really have anything cool here. I got a Nintendo DS that is not very exciting geometry, but even something like this, you could just look at it and you could say, okay, how am I going to model this in 3D CAD? Like, what am I going to do? I'm going to start with a rectangle on the main surface here, you know, on the front plane. I'm going to extrude it out. Then I'm going to design the hinge. I'm going to do that with a cut extrude. You know, like whatever it is, you want to just get in the habit of kind of looking at stuff around the house and thinking to yourself, okay, how would I build that in SolidWorks? What would the feature tree look like? Where would I start? It's just a really good habit to get into, and it doesn't mean you have to stick to that game plan, but it is a good habit to get yourself into. Because, you know, that's what you're going to, you know, that's going to help you figure out where you got to start, what your first sketch has to look like. That's always what you're trying to figure out. You know, once you get started, things start to kind of, you know, blast through, but it's always what you got to try to figure out. JMG says, I am new to the channel. Last week, I spent 4 continuous hours watching The Last Championship. Excellent. Looking forward to the next edition. That's awesome, JMG. I'm glad you enjoyed that. I appreciate that comment. I'm really glad that you found that enjoyable. We certainly had a lot of fun with it. It's always fun getting together with Dan Wagner. He's going to be co-commentating the next one as well. So very excited to be spending some time with him again. And, of course, JMG, if you're new to the channel, be sure to check out the what is it called here? Hold on, let me go to my channel real quick. Be sure to check out the playlist on, it's called Power Moves, this one here, this playlist. Power Moves, Daily Quick Tips. This was something that I did last year in March, all through April. So every day in April, I put out a new, it's like a, you know, usually they're like between 3 and 5 minute long video. Just showing you some of these time savers like what we're talking about tonight. So like how to set up auto dimensions to work in sketch mode, or how to use some of these cool right mouse button shortcuts and extrude shortcuts for ending conditions, how to make planes quickly, like how to quickly get in there and make a plane, a couple of different options there, a couple of different techniques for creating planes. So lots of good, you know, these are also really good ones to watch through and just kind of like time savers. It's not like how to use SolidWorks. It's more how to save time using SolidWorks. All right, cool. Let's get into it here with the sheet metal challenge. The print is showing me that the material is plain carbon steel. The unit is MMGS. So we'll go new here, plain carbon steel, MMGS. We'll go right plane, begin a sketch, orient the view. JMG says I did. It was useful. That's awesome. Glad to hear it. Thank you. All right, come up here. I really wanted to come up there at 30, but I missed the dimension, so that's okay. I'm going to go across here at 250, and then I'm going to come down here at 20. So this is, you know, first of all, this is an example of using your auto dimensions to save time. Always helpful to use your auto dimensions. But more to the point of the sheet metal challenge, this is an example of, like I said, this usually happens in electronics enclosure design, but the customer is saying, this is the dimension that's important to me. I need there to be 250 on the inside. I don't even really care what the material thickness is. Like, it doesn't matter to me because it's going to the outside. All I really care about is what's going on the inside. I have to be able to fit my device inside of this space. And so that's the parameter that they give you. So this happens in sheet metal. It's not as common. Usually you get your dimensions to the outside, but it does happen. And SolidWorks follows right in suit in that when you go to your sheet metal base flange tab command, you can see here that sheet metal base flange tab lets you declare, do you want that material to go to the inside or to the outside? So you see if I say reverse direction here, I've got material to the inside, material to the outside. So I'm going to say I want this to have a material wall thickness of 4 millimeters, a default inside bend radius of 4 millimeters, 30, 250, 20. That all looks good. And then finally the depth of this extrusion. So this is where those flanges are dimensioned. And this you probably wouldn't see on a real world print. I just threw that in there to make it a little bit easier for you guys as you were doing this model. So that's 182 as the distance from point A to point B on that flange. So I'm going to make that distance 182 divided by 2. Because I'm only going to model half of this thing and then I'm going to mirror it. All right, now we got our first geometry in place there. We're ready to move on, stick to our plan, pick this edge here, go to our edge flange command. Now, one thing to note is that the S key is fully customizable and it doesn't take much to customize it. So if I'm working a sheet metal job where I'm making like 50 sheet metal parts, well, you can rest assured that when I'm in sketch mode, I'm going to press the S key. I'm going to right mouse button here. I'm going to say customize. I'm going to go down to my sheet metal commands and I'm going to choose to add the sheet metal command for base flange tab so that I can jump right into that command from sketch mode. I don't have to exit sketch mode and get into that or go up to the toolbar. And similarly, when I'm out here in feature mode, I'm going to press the S key, right mouse button, customize, go down to sheet metal, and I'm going to add the edge flange command to when I'm working in part mode or feature mode. So you've got these 4 different modes that you work in SolidWorks: part mode, assembly mode, drawing mode, sketch mode. Or usually I call this one feature mode. So feature mode, assembly mode, drawing mode, sketch mode. And for each of those different modes, you can have a different shortcut menu. This is what my shortcut menu looks like for sketch mode. This is what my shortcut menu looks like for feature mode. And so what I'm doing here is I'm just kind of streamlining my workflow. Once I say once I hit the command 3 times, I'm like, that's it. I'm adding it to the S key. I'm clearly working with this command enough to justify it. So I'm going to click the edge flange command, pick this edge here, bring that edge down. I'm going to look at this thing maybe from a front view and just make sure that the flange is bending to the outside. I know that based on some of the dimensions that are in the print, some of those dimensions are showing me that there's a 4 millimeter gap there, or that the math works out for it to be a 4 millimeter gap. But I can also double check the math at the end just to make sure that I got the dimension correct. So I'm going to bring that out and make sure that the flange position is correct. So flush to material, one material to the outside, or the full bend to the outside. Oh, I'm sorry, guys. That's off screen here. It's this guy down here. Flange position. It's very important in sheet metal. So you've got your flush to material, bend outside, one material outside. You really got to be aware of that position when you're creating these edge flanges, or else you're not going to get the math correct. It's not going to work out. So we go material outside, and then finally we go edit flange profile. I'll press Control 8 to get normal 2. Maybe I'll press it again to get normal 2 on the other side. Maybe I'll hold Alt and use the arrow keys to rotate in kind of like a barrel roll. So it's not working right now for some reason. I guess because I'm in this weird mode. All right, whatever. I'm not going to worry about it. All right, so we're going to go from here down to here and then across. We're going to S key, jump into our trim command, trim this up. We're going to say this is a distance of 96 from the inside material. A lot of these dimensions are given from inside material. We're going to say this is 18 millimeters on the top here. And we're going to say that this is collinear. I don't like doing coincident. If in these spots, I try to make it collinear. I just feel like it's a little bit stronger. This is just kind of like an experience thing. And then I'm going to go from here to here and make that 104. All right, that looks pretty good. That's a view that I wanted it to be in, but that looks pretty good. I'm going to say finish. And that gives me that flange sticking off to the side with the geometry that I wanted there. Nick says, I definitely did this the slow way on on Saturday. Yeah, I've succumbed to that too. I mean, sometimes these sheet metal parts are a little bit nuanced as far as like what's the best way to do it. There's not necessarily a best way. This is just kind of the way that I do it, maybe saving a little bit of time. So here we go again with the edge flange. So I click the edge. Again, having the S key is helpful. I can click here and then just S key edge flange, bring that off. Obviously, this region here is going to be problematic. You're not going to be able to bend that. They're going to be overlapping. So I'm going to say edit flange profile, and I'm going to grab this line here and drag it up. Now, I think last week we talked about this idea of a soft relationship in sheet metal. It's a good one to go back and review that Model Monday Live from last week, just to kind of get a feel for what we're talking about there. But this is also one of these spots where the dimension is given to the center because the model is symmetric. We're going symmetric about the center. So when that occurs, a little trick that you can use is you can draw a center line at the origin, and then you can take this line here, dimension it to this line here, and then cross over the center line. So I'm going to make that a distance of 120, which is shown on the print here. 120 from inside flange edge to inside flange edge. So I only modeled half the part. How am I going to get that double dimension? I could do 120 divided by 2, right? Or I could create that center line and then double dimension across, which usually we use when we're doing a revolve command and we're trying to show the diameter. But I use it quite often when I'm doing half models and then mirroring them across. So I can say finish there. That gives me the flange. I think this thing is looking pretty good. It looks a little bit funky, but I think it's just because I only have half the model so far. Pick this face, begin a sketch, orient the view. I'll leave the view how it is. Do a slotted hole here, a width on this slotted hole of 10, a distance from the bottom here up to the arc. I always try to dimension to the arc, not to the center point itself. I let the software pick the center point, but it gives you a little bit of flexibility if you ever need to go back and adjust it to tangent point. You won't get that flexibility if you dimension to the actual point. So that's another little pro tip there. Dimension to the arc itself, not to the center point. I know it's going to the center point this time, but when you dimension to the arc itself, there's a section over here under leaders, down at the bottom, where you can see that you can define it as being to the center, the minimum point of tangency, or the maximum point of tangency, and you won't get that if you dimension to the center point, the point itself, that is. And then here, again, so much of SolidWorks is these kind of nuanced pro tips. But here what I want to do is I want to create a double dimension like I did before. So I pick this line here and I pick this line here, and the double dimension doesn't show up. Why doesn't the double dimension show up? Because I went from a center line to a center line. So SolidWorks doesn't know which center line the double dimension should go over. So instead, what you could do here is you could dimension from this point to the center line, and then you can double dimension across it and then type in in this case, 150. So, these are little things that you learn over time, but they can just kind of save you a little bit of frustration when you do that. All right, and then we're going to say link to thickness. That way the cut extrude automatically picks up the thickness of the sheet metal. I think we talked about this 2 weeks ago and also talked about it last week. It's what's called a linked value. Very useful. If you want to learn more about linked values, just go back to that episode from last week. You'll learn a lot about that too. And especially 2 weeks ago, you'll even learn a cool little exploit. Not the Ivan exploit, but a cool little exploit. Eric's showing that Hole Wizard does slots as well. Yes, that's very good to know. And then Eric also made mention here of a program some of you guys may have heard of, may not have heard of, but it's called X Sheet Metal. So this is part of 3D Experience, their new entirely browser-based CAD solutions. So you can do it from any computer, and when you're done, you're saving into the cloud, so you could jump from one computer to another, and all the calculations are done in the cloud. There's one called 3D Creator X Design, which is one that I'm really learning a lot about right now. There's also one called X Shape, which lets you like push and pull models, and there's also one called X Sheet Metal, which lets you do sheet metal design entirely from a browser. So that's another kind of a cool solution that's out there that I'm sure we're going to be hearing a lot more about in the future. And Table 36 is saying, I just did the math on both. Yeah, that's good too. I mean, this spot is easy, but sometimes you get a dimension that's like 75.6825, and then you got to divide it in half, and you could always do the /2 That's always a good one to know too. Or maybe you can just do it in your head. All right, here we go. We're going to take this face. We're going to features, mirror, just like before. This is going to be bodies to mirror. You can do that with sheet metal. When you model sheet metal and you mirror it, you still have the ability to flatten it, which is nice. So when you mirror about the body, you can actually just still, flatten it, no problem. Pick a face, begin to sketch, orient the view. And then I think table 3.6, you had said earlier about using contours. This is probably a spot where I would use contours or just do it as two separate cut extrudes, but that seems a little bit extreme. So I would do auto dimension here to make that 130. Take this point, hold control, take this point, let go of control, make them vertical. And then I would do my rectangle here like so, and I can just take this point, hold control, take this and make it midpoint. And now everything is kind of centered, and all I need to do is put in the width here of 50, and then the dimensions, which are coming from inside material to here at a distance of 50 as well, and then inside dimension to here to the arc at a distance of 130 as well. And so now you got a fully defined sketch. Pretty straightforward, pretty easy way to fully define that sketch, as opposed to like trimming it up and then having to, the slot is going to want to move side to side. You'd have to like put in some kind of anchor point to get the midpoint here. Or, you could right mouse button, select midpoint. But yeah, I mean, that's kind of how I would think I would do that. S key extrude, link to thickness is already selected. And then I would just do select contours and get these guys here. And give it one final spin, kind of look at the print, say, does that look right? Maybe do a quick dimension check, because this is telling me that this is 198 and this is 258. Well, one of my favorite time savers in SolidWorks is pick one, hold control, pick the other, and then just look down here in the, it's called the status bar. And the status bar tells you what the distance is between the two things you picked. So that's 198. All right, perfect. And then this one is supposed to be 258, and I look down here and it says 258. So I know that I got those dimensions correct, which makes me feel very confident that everything else is correct. So let's take a look at our evaluate mass properties, and we're coming up with 2172.57. I actually don't think that that's right because I usually don't have something like a .57 in there. So let's just look and make sure nothing else looks out of line. These flanges here look out of line. I usually don't have a... The reason I knew that it was wrong is because I don't make the answers fall in the middle of a value, like a 0.5 like that. I wouldn't do... Oh, here it is. Look, this 18 is wrong. So I dimensioned that 18 like so. I should have dimensioned it to the inside of the material. Dang. I can't believe I gave you guys one that was that tricky. Nope. 18. All right, let's try this again. Mass properties. 2163.09. Yeah, there you go. That seems more right. There's another little exploit, I think, on my challenges. If I ask you for an answer at, in grams at, maybe I shouldn't say this. I don't want to necessarily hold myself to this, but just generally speaking, if I give you guys an answer and I'm asking for it in whole grams, I'm probably not going to have it fall close to 0.5 because it's too subjective. I don't want somebody to like get tripped up because it was like 0.57, and you're supposed to round it up to the next gram. They're usually going to land pretty close to the full gram mark. But now that I said that, don't hold me to that, especially during the tournament. During the tournament, it's kind of like just go with whatever I come up with. There's so many models to make. All right, cool. We did it. Oh, wait, did we do it? What did I say? It was 2163. All right, here we go. We did it. 2163. We did it. Got it right. All right, awesome, guys. We got one more. Fortunately, this last one I think is probably the easiest of the three from Saturday. Take a little sip from my water. Rodriguez says, I don't trust my math. I always use the /2 trick. It's a good trick. Very good trick. Definitely a trick that I also use quite often. All right, here we go, guys. Let's finish this out with this last one here. Before we do, let's make a quick announcement. April, the month of clean sweeps. During April, you can win all three. So during the Saturdays in April when we have the contest, which is either going to be 3 or all 4 Saturdays. It'll probably only be 3 Saturdays. Usually I save that fourth. I leave that fourth Saturday open But during the Saturdays in April, where we have the competitions, you can win all 3. You can clean sweep. So we're going to see people going from 0 points, possibly to 3 points in one single event. It's going to be a bloodbath. We're going to see what happens. See how people are moving up and down the leaderboard. Ivan actually has 4 points. This is actually the wrong slide here. This should have had the updated points. Sorry, Ivan has 4. Parge has 2. And Rodrigo has 2. That's the updated board. Here's our materials. Here's our final print. I call this one Cheap Tool. Cheap Tool. Here we go, guys. If you want to follow along with, take a screen capture. I'm going to kind of blast through this one, so I'm only going to leave this up for a few moments because we are winding down on our time together. Cheap Tool. I like this one. It's always the same things. What is my starting sketch going to look like? Take a look at this thing and see what your starting sketch would look like. Where is my starting sketch going to land? Is the model symmetric? Does that help me? Right? The model is symmetric, but does that help me? Can I get away with just modeling half, and would it even help me if I did? Right? These are all good solid questions to ask. Is there any, like in this case, there's a pocket. Is there anything going on with that pocket that I should know? I mean, it looks like the radius is coming from the center point of the 2 circles. It looks like the sidewall is offset by 0.25. Is it possible that radius at 0.9375 radius is also offset by 0.25? Does that work out? If I take 1.375 and I divide it in half and then I add 0.25, does that get me to 0.9375? If I take the diameter of that lower circle, which is 3, if I divide that in half to get to 1.5 and then I add 0.25, does that get me to radius 1.75? Maybe I could save some time and, kind of offset all those faces at the same time. I don't know, right? Let's get into it here and find out. But these would be all things that I'd be thinking about, and then it would come time to come up with my game plan. And for this one, my game plan is going to be create this all-in-one shape. It's good to learn how to create that all-in-one shape because you see this all the time in mechanical engineering. So it's good to get into that kind of practice of how quickly you can make that shape. There's some cool things you can do with contour selection as well at that spot. But I think it's just, even if you're just doing it with line, arc, line, just learn how to make that shape. All right, next thing is I'm going to create this secondary base that's going to come up to the top. Maybe this secondary base here that's going to come up to the top, and then this tertiary base here that's going to come up to the top. Next thing is I'm going to need to create this cutaway. And this cutaway looks kind of weird. Like it looks almost like things are drafted, but there's no draft on this, not really. I mean, there's this angled region down here, but it's not really like traditionally drafted. So I just need to create this cutaway, blast that through that face. And then I should be ready to move on and do the final feature, which will probably be the hex. That final feature, that final cut extrude feature at the bottom. The only other thing that's a little bit weird is, you have to figure out where this pocket is, but you kind of know that from this cutaway, and you have to figure out what this final pocket here is going to be. Probably save that final pocket region there till the very end. Pretty close to the end. All right, let's do it, baby. Here we go. New. This is ABS, and it is in inches, which everybody loves. If you go on the SolidWorks Discord and you talk about IPS, they will all love you and give you lots of shout outs. All right, so this is going to be, so like I said, you can do this with contour selection, or you could do it with just kind of like line arc. A couple different ways you can do it. I think it's good to learn how to do it both ways, but since I already started here doing it this way, I'm just going to commit. I'm going to say that's going to be 3 inches. I'm going to create an arc on this end, which is going to have a diameter of 1.375. I'm going to hit escape, pick one, hold control, pick the other, let go of control, make those horizontal. Do a smart dimension between these two, which is at a distance of 5. And then I'm going to create a line that goes from this arc to this arc. And sometimes if you do this just right, you can pick up tangency on both of them, and it's a beautiful thing. It only usually happens once per model. I wouldn't expect it to happen again, but who knows? Maybe I'll get lucky. Nope, didn't get lucky. So now I'm going to do, this is another kind of cool trick you can do. Sometimes you could do a crossing here and then make them tangent. So like you have a window select, which goes from the left to the right, and then you have a crossing select, which goes from the right to the left. And if you do that crossing select, sometimes you can like get away with doing make tangent there. Same thing here, I could try it. Oh yeah, we got it. Again, it's a little nuanced, but these are like little things you learn over time. S key extrude. This is going to go up to a height of 0.5. Enter. Pick the contours. Right mouse button to finish that command. Select face. Begin to sketch. Orient your view. And S key circle. And now this circle is going to start here, and it's going to come over to this point. If you pick the point of tangency, then you can get that to be fully constrained all in one shot. If you don't, then you could always, pick one, hold control, pick the other, let go of control, make co-radial. That definitely works. S key, extrude. I think I did this wrong because I probably should have done this from the very bottom face. When I find myself in these spots, the customer is telling me that they want it at 2.5. So it's going to be up to me to make a decision. I can either edit sketch plane and just move it down, or I could do the extrusion and say offset from surface and then pick this surface here. There's a couple different ways you could do this, but you do kind of want to capture what the customer's asking for. So let's say I did offset from surface, and then I made that 2.5 since that's what the customer's given me. And then I said it's offset from this surface, and then reverse the direction. There we go. And then usually what I'll do is I'll just double click on the feature real quick just to make sure that, double click on the feature just to make sure that the 2.5 is coming from the correct spot. This again, if it's a speed run, I'll probably just do 2.5 minus 0.5, or I could probably even do that in my head, believe it or not. But when you're doing it for a customer, if a dimension is going to change, it's going to be this dimension, and you kind of want it to be there to make that conversation a little bit easier in the design review meeting. All right, now I'm going to pick this face, begin to sketch, orient my view, and I'm going to offset this 0.375 because it's saying 0.375 wall here. So I'm going to offset this 0.375. So this is another, great spot to save some time. When you pick a face and you begin a sketch, the face is already highlighted, so you can just jump right into offset entities. 0.375, enter to update the preview, reverse direction, hit the green check mark. There we go. S key, extrude cut, and that's going to be 1.25 offset from surface again, and the surface is going to be this surface here. I know that 2.5 divided by 2 is 1.25, but again, it's just kind of like a good thing to do to get in the habit of matching the customer's design intent. It's just a good, just good. These are just good practice, little tips for when you're actually working with a customer. If it's a speed modeling contest, I know you're going to take some shortcuts, but I'm trying to teach you how to be fast, but also to still be accurate. So now I've already got a plane running through here. This is like origin selection strategy. Most of the time you just get lucky. But in this case, I did get a little bit lucky. I just happened to, if there's two circles and one of them's larger, that's probably the one that I'm going to put on the origin. This is a little arbitrary, but I happened to put it right there. So that means I've got a plane running this direction, which is going to set me up nicely for this cut extrude for this kind of slotted region here. If I didn't have that plane there already, what I could have done is shown the sketch of the circle and then offset a plane to that sketch. So let's say, for example, it was this region down here where I needed the plane. Well, a lot of times in that spot, what I'll do is I'll show this sketch, and then I will single click on the right plane, put my mouse over the right plane so it becomes a four-way arrow. So it's got the little crosshair there. That's when you hold control on your keyboard and you begin dragging. That's a shortcut to make a new plane offset from the starting plane. So instead of having to go into insert reference geometry plane, you just need to know the shortcut and it gets you to the same spot. And then without doing anything else, all I did was hold control, drag an arbitrary distance, let go of everything. And then I come down here and I single click on that point from the sketch. Then I can immediately right mouse button to finish the command. So I come down here and pick on this point from the sketch, and then I can immediately right mouse button, which is going to make a plane parallel to the right plane at that point. So if I did need the plane, that's how I would do it. This happens all the time. It's good to know that you can show your sketch, that you can bring the plane over, drag the plane over, pick that point, right mouse button. It's just a good, quick way to make a plane. And now I'm done with the sketch, and I'm done with the plane. So how do I hide them? I almost never go over to the tree and hide them. I just click on them out here in the graphics area and then look for the little eyeball. It used to be a pair of glasses. Look for the little eyeball and just click on it. So I just left click on the sketch, click the little eyeball. You don't have to go over to the tree and find it. Just do it right there. Right plane, begin a sketch, orient my view, S key, extrude cut. This is kind of like a feature creation thing where I knew that I was going to be cut extruding through all in both direction. So I decided to save the geometry at this end. Like at this end, there's going to be a boss that comes up and then another boss that comes up, and then that's going to get in the way of that cut extrude. So I just decided to kind of strategize the order of my feature creation. To get this thing centered, a couple of different ways you could do it, but usually what I would do is I would just draw a center line that goes from this point down to here, and then I let go, and then I come over here and I make that vertical. Why not just right mouse button select midpoint? I just like having the visual cue that's related that way. You could definitely do that, right mouse button select midpoint. It's never really been my style, but you can definitely do that. Pick these two lines and make them equal, and that should establish symmetry on that slot. Go to your hidden lines displayed here and get normal 2, and then you could take this, hold control, take this, make those collinear, and now we can just put in those final dimensions, 1.75 and 1.125. S key, extrude cut, right mouse button, through all in both directions, right mouse button again to finish. There we go. Yes, that is looking good. Let's tackle this end down here now. Select face, begin a sketch, orient the view, S key. This one is, again, probably should have sketched it on the bottom surface. This one has a diameter of, it's a matching diameter. Sweet. Okay. Here what I could do is exit sketch, right mouse button on that sketch itself. And then when I right mouse button on that sketch itself, I can go in here to edit sketch plane and just push it down to this lower surface. Okay, and now I can S key extrude, and that's going to be 1.75, just 0.75, not 1, just 0.75. And then again, lesson learned here, sketch it in the correct spot. Finally learned my lesson. Diameter here of 0.75, S key extrude. This is going to go to 1.5, enter, right mouse button, reverse direction, right mouse button again. There we go. And then for this hex here, I can pick this face. I can go to my begin a sketch, go to my polygon tool up here. It's going to be 6-sided polygon, single click on the origin, a little bit of strategy with regards to where the origin was selected. Pick this line, make it horizontal, S key smart dimension from here to here at a distance of 1.5 for that hex. Nope, 1.5. S key, extrude cut, right mouse button, through all, right mouse button. And then finally this little pocket here, which I alluded to earlier, it is a uniform offset of 0.25, so all the math does work out. You can definitely double check it after you do it, but this is an offset of 0.25, this is an offset of 0.25, this is an offset of 0.25, and this is also an offset of 0.25. So what that means is we could pick this face, begin a sketch, jump right into offset entities, make that 0.25, enter, reverse direction. There we go. Hit the green check mark. And then if you want to be sure, just drop some driven dimensions on here. So make that 0.75, make that 0.938. When you click on it, you can see over here 0.9375. But just drop some driven dimensions on there if you're not sure, or if you think the customer is going to want to see those dimensions on the print or something like that. Just drop them on there as driven, and then you're good to go. And then for our pocket, this is going to be S key extrude cut, and it looks like it is offset from surface 0.25, which again, I know that's half of that distance, but just to match the customer's expectation, we'll make it offset from this surface so that our 0.25 dimension is going there, just like what the print's showing. And then we finish up here with S key fillet, and we start out by typing in the fillet radius, 0.25, enter. Then we single click on one of the edges, and then we move our mouse up and to the right, and we look at these fillet shortcuts. And whatever shows up in magenta is going to be what gets filleted. So look, I could get 64 edges here in one single click if I wanted to. That's not what I want. I want to get 4 edges in one click. So I single click, it gets all 4 of those edges in one single click. And I think that's it for that cheap tool. We go to our evaluate, we go to mass properties, we see it comes out at 3.59 pounds. Wait, I don't think that's right. Oh, I have this thing as plain carbon steel, that's why. So let's go here to edit material, just go to ABS, and let's try that again. The reason I said I don't think it's right is because this print is saying 0.XX pounds. So that's how that was what tipped me off. All right, mass properties, 0.47 pounds. That sounds a little bit more correct. Let's see if we got it correct here. This is where I get so nervous. All righty, here we go. Correct answer is yes, we did it. We got it right again. 0.47 pounds. What's up, Mandy Shaner saying, loving the keyboard cam. Good. I'm glad you're enjoying that, Mandy. Hope that it brings you much joy. If you want to see more of it, you can go back to some of the previous episodes. And John Luca is saying, hey, Toby, came a bit late today. No worries, no worries. It's video on demand. You can always roll back and watch how we went through and built these models. So I think that's going to wind us down for the night. I want to say thank you all so much for tuning in and remind you that on April 3rd, we got some special guests coming in with Kirby and Johnny, the Core Podcast. And then on April 4th, I think Eric Beatty is going to be on the Core Podcast on their show. They're going to be on my show on Saturday, and Eric's going to be on their show the following day. So be sure to tune into that as well. Don't forget April 6th, we got the Seattle Users Group 25th anniversary users group meeting. Definitely want to check that out. If you guys enjoyed the live stream tonight, be sure to give me a 1 in chat. It's been awesome doing these live solves with you guys, and I hope that you have found these helpful and insightful. And of course, you can always go back and look at the earlier episodes, and you can always share these with anybody. I see that Natsumi is saying, may I try Toby's model in Japan? Yeah, absolutely. Go for it. Give it a try. See what happens. It's a worldwide contest. We run these every Saturday at 1500 GMT, Natsumi. So if you look at last week's episode, you can see what that works out to. But it's a 1500 GMT. I'll have the new one posted probably later tonight or tomorrow. But definitely feel free to tune in from Japan. We would love to have the international audience. We want to see who's the fastest in the world. You have the opportunity, Natsumi, to earn points this month in April. You can clean sweep every episode so you can get enough points to be at the top of that leaderboard at TooTallToby.com, which will get you into the tournament if you want. What's up, Tom Smith? It was great seeing you in here tonight. Love seeing all the feedback from everybody. So that's it, though. We're not going to do any more of these live solves because this month I got to really focus on getting the tournament to go. So, yep, Saturday is a go, table 3-6. It's 1500 GMT, which is it's 11 a.m. for me. Different times for different people around the world, but it's 1500. I figured out how daylight savings works, so I think I got it right on now. What's up, Chris Knudsen? Great to see you in here. Old friend of the show. Wonderful to see you in here. And I want to just say thank you all so much. What's up, hell yeah? Great seeing you in here as well. Very, very old friend of the show. Thank you so much for tuning in. Great seeing everybody in here. I will look forward to seeing you guys on Saturday. We got special guests coming up this Saturday with Kirby and Johnny. And be sure to mark your calendars for next week, April 6th, for the Seattle Users Group 25th anniversary. It's going to be an awesome time. All right. Thanks, everybody. It's been great. See you guys next week or on Saturday. Bye.